Welcome to the review of Unit 4, Chemical Bonding. Monatomic ions are single atoms that gain or lose valence electrons to carry a net charge. So on the left here I have pictured some monatomic ions. So if you have an atom of fluorine, it will gain an electron to become F-. Something like sodium will lose one electron to become Na+. Those are all monatomic ions. Polyatomic ions are ions that consist of two or more atoms and as a unit carry a charge. So those are things like OH-, that's made up of oxygen and hydrogen. Cn-, which is made up of carbon and nitrogen. So in monatomic, you only have one type of element, you have a charge. Polyatomic, you have two or more types of elements and a charge. One hint here is for monatomic, look for one capital letter. For polyatomic, look for two or more. In many cases, the type of ion that an element forms can be predicted from the periodic table. So here I have the charge listed above each group. So for group 1, that's everybody below hydrogen, they get a charge of +1. Remember, hydrogen is special. It could also get a charge of -1 as well. So just keep that in your brain. Group 2, they all have a charge of +2. Group 3, they all have a charge of +3. Group 5A, that's nitrogen and below, they all have a charge of -3. Oxygen and below, they all have a charge of -2 when they ionize. And then group 7, they all have a charge of -1, so from fluorine down when they ionize. Noble gases do not form ions, so they never are charged. For the transition metals and the inner transition metals, their charge cannot be easily predicted, and when you're naming them, you have to use a Roman numeral. Metals and nonmetals exchange valence electrons and form stable, strong ionic bonds. How does that happen? So first you have, in this instance, sodium. Sodium has 1 electron in its outermost shell, and you have chlorine. Chlorine has 7 electrons in its outermost shell. They both want 8, so what happens is that sodium gives 1 electron to chlorine. Chlorine will now have 8 electrons in its outermost shell. Sodium will lose its shell along with that 1 electron, and it'll now have 8 in its outermost shell as well. Sodium will get smaller, chlorine will get bigger, just going back to the previous unit. And you end up with Na+, which has lost an electron. When you lose electrons, you become positive. And Cl-, who has gained an electron. When you gain electrons, you become negative. Now when you have that plus and that minus charge, they're very attracted to each other. Positive and negative are incredibly attracted to each other, so you form that very strong bond. And eventually it'll form a crystal lattice when you have enough of it. Covalent bonds form between atoms, usually nonmetals, that share pairs of valence electrons. So unlike an ionic where you're actually giving an electron away, covalent bonding involves sharing. And you can actually see their orbitals are overlapping. So these two atoms, maybe this is hydrogen and this is hydrogen, and they're sharing these 2 electrons. Those electrons are, and you can actually see like the orbital overlap right there with the 2 electrons. That'll be the bond right there. Metallic bonding is a little bit different. You basically have a sea of metal cations surrounded by electrons. So these metals their valence electrons just kind of flow freely. So this electron here might have originally belonged to this metal up here. So when you think of metallic bonding, think sea of electrons. This chart just breaks down the types of atoms involved, the electron behavior, and the properties for ionic bonds, metallic bonds, and covalent bonds. So this is an excellent tool for you guys to study from. And you can pause the video right now if you want to read through it. Lewis dot diagrams represent covalent bonds. Here, basically what you do, you figure out like what your formula is. If it's CH4, you would kind of draw your carbon in the middle because you know carbon has 4 valence electrons. It's going to need 4 connections. And so in between each one, you would draw like this is, these black dots represent carbon's 4 valence electrons. Here's hydrogen's 1 valence electron. This hydrogen has a valence electron. This hydrogen has a valence electron, and this hydrogen has a valence electron. Anytime you have 2 dots in between 2 atoms, you represent that as a line. So this line is a single bond. It represents the sharing of 2 electrons. Same thing with this one, and this one. So you would just draw lines where you have 2 dots in between 2 atoms. Here's O2 down here. You can see originally you would have had 4 dots in between the 2 oxygens, and then you just convert it to the lines. So these are all Lewis structures. These are all for covalent bonds too. You don't really use Lewis dot diagrams for ionic bonds. I mean, I guess you sort of do, but not the same way that we talked about them. And the last thing we talked about in Unit 4 were those intermolecular forces. These are weak attractions that affect the properties of substances, such as boiling point and melting point. We talked about 4 different kinds: dipole-dipole forces, hydrogen bonding, ion dipole forces, and London dispersion forces. And then this chart just goes through what types of molecules do this, and how does it affect the properties, and some examples. So if you want to pause the video, you can read through this if you'd like.